Hey everybody, and welcome to today's webcast, System Hardening Without Affecting Production Services, sponsored by Calcom. I'm Chris Flack with Redmond Magazine, and thanks for joining today's Redmond Tech Advisor webcast. We greatly appreciate that. Now, just a few quick things before we begin today's presentation and introduce our speaker and presenter. Just a few quick things before we begin. So first things first is we will be doing a live Q&A at the end of today's webcast. However, we do encourage you at any point during today's presentation, if you have a question for our presenter, please feel free to enter it in the Ask a Question box on your console, and hopefully if time permits, we'll get to everybody's questions and get out some answers. Also, today's webcast is being recorded and archived for future viewing and listening purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's presentation. Please feel free to share that link with coworkers, colleagues, friends, anybody who may be interested on today's topic. We would greatly appreciate that. Joining us for today's webcast, we have a really great presenter. His name is Adam Bertram. Adam is an independent consultant, technical writer, trainer, and presenter. Adam specializes in consulting and evangelizing all things IT automation, mainly focused around Windows PowerShell. Adam is a Microsoft Windows PowerShell MVP for 2015 and a PowerShell hero, and has numerous Microsoft IT professional certificates. He is a writer, trainer, and presenter, and authors IT Pro course content for Pluralsight. He is also a regular contributor to numerous print and online publications and presents at various user groups and conferences, and you can find him on numerous webcasts just like this one. You can find out more information about Adam at adamtheautomator.com. And without any further ado, I'll let Adam step in here so that way we can start today's presentation. So take it away, Adam.
Hello, and welcome to our webinar, System Hardening Without Affecting Production Services, presented by Adam the Automator. A little bit about me. My name is Adam Bertram. I do a lot of training courses through a site called Pluralsight. I do a lot of things in PowerShell. I'm a PowerShell trainer, a consultant. I also do a lot of technical freelance writing. If you want to get a hold of me, you can get a hold of me at adamtheautomator.com, or you can get a hold of me on Twitter at adbertram. The IT security industry has always been a game of cat and mouse. The bad guys are constantly coming up with new ways to exploit vulnerabilities in your business. The good guys are then fixing these vulnerabilities as fast as possible and coming up with new ways to protect themselves. Unfortunately, though, the cards are stacked against the good guys. Why? Well, it's because it's much easier to look for flaws in a system and exploit them rather than to protect the system as a whole. All a bad guy needs is a single point of entry. That entry doesn't even need to be some complicated malware like Stuxnet, for example. But it could be just as simple as Susie in HR getting an email that says she's a lucky beneficiary of that price in Nigeria. The good guys have to worry about all the technical attacks like zero-day attacks, intelligent malware, viruses, worms, and the like. They also, though, have to worry about the human element. The Susies of the world, plus forgetful or inexperienced admins that leave network and server configurations wide open to the world, or simply don't keep the firmware or software up to date from the manufacturer. Nowadays, it's becoming more common for security professionals to simply assume that a breach has occurred and put forth a plan to mitigate the impact rather than trying to prevent all attacks. This is the state of the industry now, unfortunately. I remember when I just got started in my career in IT, it was considered good enough to have a locked-down network perimeter with a firewall preventing incoming traffic. In addition, we'd ensure that we had antivirus software on all servers and computers and ensured that we kept the virus definitions up to date. Nowadays, that's not near enough. It's important to first start with a hard foundation and work from there. It's important to first remove any feature that's not necessary. This is to reduce your attack surface. Of the features that you do need, you'll then need to harden your operating system itself. For example, Windows, it's an extremely complicated operating system. Unfortunately, what comes with that complexity is an inherently less secure system. This is one of the reasons they're releasing server products like Nano Server nowadays. Most admins know this and try their best, but once they get into a group policy object, for example, and start looking around, they soon become overwhelmed with the number of policies that exist and things that can be modified. On top of that, it takes a full-time security professional to really understand all those changes. If you're able to survive the OS hardening task, it's then you should begin to rely on third-party software for protection like host-based antivirus, malware protection, and the like. What I alluded to in the last slide was simply system hardening. System hardening can mean lots of different things, but when I think of system hardening, I think of eliminating as much extra stuff as possible. That's stuff that's on a server that's really not of use. This reduces the attack surface. I also think of system hardening as doing research and figuring out what out-of-the-box settings need to be applied in order to call a system, quote-unquote, secure. System hardening is about following best practice guides or scanning your system with vulnerability scanners to find out out-of-date machines with known exploits. Also, it means testing these proposed changes in test environments, and if they look good, making configuration changes to your systems in order to reduce the risk as much as possible. Now, you probably already know what you should harden in your servers, but why? Well, this might sound obvious at first. It is to make them more secure, right? Well, what's secure to a sysadmin is probably different than what secure means to a security architect or to a business professional. Let's go over 3 reasons why you need to harden your systems and get a glimpse into what secure might mean to different categories of people. The first reason to harden your system is compliance. Most of us either are or had to deal with some form of compliance tasks in our career. Although it's not necessarily a fun task to prove yourself to anyone, it's a necessary evil when faced with inadequate security measures being taken by some companies. An overseer is required. Auditors love that magic word, in compliance. The truth is, really everyone does. Proving that is a different story. One of the main reasons why no one likes compliance is because it's been really hard to define. Since most compliance agencies don't release strict requirements, it's up to you and the auditors to come to the conclusion if you're truly in compliance or not. However, even if these regulatory bodies would release specific requirements, most businesses would still be hating life when the auditors come into town. Why? Well, it's because they don't have the tools in place to quickly discover all the information they need to bring to the auditors. 9 times out of 10, when I've been asked to provide some kind of report for an auditor, it always ends with a grimace. It's because it's usually going to require a lot of extra effort because I haven't put a system in place to gather the information ahead of time. There are plenty of tools out there that allow you to harden systems and provide reports out of the box that can be run at will. These reports can then be handed off to the auditors and they can be on their way. Reason number 2 is data leakage. The last time I checked, your customers would rather not have their personal information spread out all over the internet. When systems aren't hardened, vulnerabilities can be exploited and data can be easily stolen right out from under the nose. I've read numerous reports about breaches that are discovered even years after the fact. This site, haveibeenpwned.com, is a site that goes out and collects all these dumps from all these data breaches and merges them all into one massive database. It then gives you the ability to look up your email address to see if it's been part of a data breach. If found, it will then show you what data breach incident that email came from. Now, this is not what you want your customers going to and finding out that their personal information was leaked to the internet because your systems weren't hardened. It looks bad not only on IT but the entire company. There have been CEOs fired because of data breaches. This is how high profile these events can be. How would you like your company to have a Wikipedia page forever online as a remembrance of the inadequacies of your system hardening procedures? Not me. I don't want to be the IT manager that doesn't implement a tool to monitor vulnerable security settings on his servers because it's deprioritized. Security software is like insurance. You hate to spend the money on it because right now it's not providing any value. In fact, it can sometimes bring negative value in the form of unforeseen downtime when a patch is installed on the system, or maybe a critical user account is disabled that wasn't thought to be of any use anymore. We've all been there, and We've probably all been burned by some change that security has needed us to do, or only just maybe patching a system and had brought it to its knees. However, as you can see from Sony's PR nightmare here, like insurance, it's well worth taking the time, getting it right, and taking the slight risk of some downtime now and then. I'd much rather a production server go down and my customers not be able to access a service rather than having their information spread out all over the internet for all the world to see. You'll soon see near the end of this webinar some tools that could substantially decrease the chance of downtime when implementing these system hardening configuration changes. So now that I've convinced you, and I have convinced you, right? Okay, so now that I've convinced you just of the 3 of the reasons to harden your system, here's 6 steps on how to make it happen. Step 1, reduce your attack surface. When you provision a new server, eliminate as many features as possible and do not install any software that's of no use by whatever service that server was built for. By simply reducing everything you can, this naturally reduces the attack surface of the system and provides fewer ways for an attacker to exploit any vulnerabilities on there. Less stuff typically means less vulnerabilities. Step 2 is to discover the vulnerabilities. This can be done in some different ways. Whether you use a tool like Nessus, Qualys, or one of these other ones here, or you're just using something like Windows Server Update Services to measure patch levels on your Windows systems. You first must know the kind of attack surface you're working with once you've whittled it down to as small as possible. Step 3 is to build a test environment. I don't have to tell you, it's not necessarily good practice to test in production. You'll need to provision some environment in a segmented off place on your network to test changes. This complexity of this sometimes lead to some admins to skirt this system and slip in a little production changes here and there. This is a recipe for disaster. This small change might be a dependency for 10 other applications that you really didn't know about. Step 4 is to apply the change in production. So you've tested it out in an environment that you think looks like production and you're good with it. It's now time to wait for the change window and just do it. Which leads us to static when they become too complicated. I've personally had times when an organization has built up hundreds of these GPOs over time, and it's really tough to decipher which one has precedence over the other one in all these different kind of circumstances. Next is configuration management products. These are products that were specifically designed to change various configurations on your servers and keep them that way. These kinds of tools include things like Chef, Puppet, Ansible, and the like. Those are great for defining a set of configuration items and targeting specific servers. However, these tools typically aren't free and require some training time and get up to speed. They also aren't system hardening specific either. You'll have to figure out how to map your hardening strategy to the tool. Next is ad hoc scripts. Scripting has been around for a long time, and you can technically do anything with scripts you can do with these tools. However, scripts have a significant disadvantage of not typically being used for large environments. They're hard to organize, and eventually they become unwieldy if you've got hundreds of scripts spread throughout the organization changing this and changing that. And finally, we come to a tool that Qualcomm software produces. Now, this is a tool designed specifically for system hardening. It provides a one-stop shop for all your system hardening needs, from suggesting settings to change, testing the changes, and making the changes and keeping them that way. So let's dive a little bit deeper and discuss a few real scenarios that you might find yourself in. The first scenario is password change scenario. A password change to a user is no big deal. They simply hit Control-Delete, change password, and they're now using a new password. A password change for an account can be the complete opposite if you're in IT, especially if it's a privileged account. One primary hardening recommendation is to enable a policy called network security. Do not store LAN manager hash value on next password change. This is a policy that, although it's great for security, since the password hash isn't stored on a local machine, Thus, it's being potentially exposed. However, on the other hand, if the hash isn't stored locally, if an application has been configured to use the old password, it can break. For example, if there's a scheduled task set up that's depending on that password, it'll break. If there's a Windows service that's depending on that password, it'll break as well. Same thing with logged in users. A good example of this, to come back a little bit, first is the scheduled task. When you build a scheduled task, you can either choose to run it as a domain user, which saves the hash, system, which doesn't save the hash, or as a local user, which does not save the hash. To ensure an application doesn't break, you need to account for little details like this. I don't know about you, but there's been many times in my career where I've configured a scheduled task to use a domain user account and forgotten all about it. That is until the password was changed. Have you ever considered just how many dependencies exist in the simplest application? Even the smallest application configurations you might have on just a single machine hosting a web server, and maybe you have one that hosts a database or two. In this scenario, you've got dependencies like a website depending on the website depending on a particular database tables, the database depending on resources from the server, the database's security logins, and all this other minutia that comes with a particular component. There are dependencies galore. Luckily, the software developers sometimes prevent us from doing something stupid by accounting for these dependencies in the software itself. But there's no way for them to foresee all the crazy environments their software is going to be installed in. It's up to us to account for these dependencies on our own, and this is really no easy task. To solidify this problem, again, let's talk about some real-world scenarios on where this might apply. The first is Windows services. A typical hardening task is to stop or disable a Windows service. This shuts down an executable program and potentially closes an open port or more on the machine's network stack. However, do you know what depending on that service? Well, usually the service isn't the same name as a familiar application, and the only true way to know is to look at the application configurations to find out. One that sticks out in my head is when I restarted the W32 time service on the server a long time ago. I did this and I accidentally found out that it took the entire Windows cluster down because it got out of sync. That's just one simple example from my personal experience. Also, what about services depending on one another? Now, this is easier to spot since it usually comes up when you try to stop a service, but wouldn't it be nice if you could just see all these dependencies ahead of time? Another dependency scenario is the usage of anonymous. Anonymous usage can be in lots of different places, from IIS application pools or indirectly by DCOM or other pieces of software. Anonymous could be in the service or far from it. It's tough to detect all transactions using that anonymous account. You really have no way to identify what's using this anonymous account until you disable it and find out the hard way. On top of that, if you ever look in group policy under security, you'll find 8 different policies all making reference to anonymous. Another widespread problem with testing is what I call the red tape testing. This involves all the hoops you must jump through to get a change put into production. This is where our friend change management comes into play. If you work in a large enterprise, you probably know what I'm talking about here. You submit a change ticket, wait a week, and then get approval for a change window in maybe another week or two. It's a frustrating experience. This is necessary due to the complexity of the systems, but doesn't have to be quite so painful. If your organization can show the testing procedures you're going through before asking for a change in production are sound, you might get some leeway here. Testing is not only necessary regarding merely ensuring nothing breaks, but good, thorough testing always gives you more credence as well. If you're able to prove that your testing procedures are well thought out and cover as many potential problems as possible, you will become trusted and can sometimes get changed into production faster. Now, this is the result of server hardening initiatives. It's typical. Since server hardening can easily affect production services, Ops hates to make these changes. But it's security's job to recommend them, as I mentioned before, and enforce those changes. Sometimes it can end up in a stalemate where your infrastructure is wide open and vulnerable to different attacks. You know, it's a kind of a damned if you do and damned if you don't kind of situation. Everyone knows what they need, better security. However, no one wants to actually make the changes to make it happen for fear of affecting production. Since it's so hard to replicate production in a testing environment and sometimes takes weeks just to get an environment up at all, some just skip the test environment altogether. Now don't lie. You know you did this at least once in your career. Some of you impatient ones more than others. You know, I have personally many times, I'll admit it, and it's burned me. It wasn't because I didn't care about affecting production. It was simply that I had too many things on my plate that I felt like couldn't wait. The testing process was way too time-consuming, and at the pace our team was going, it simply wasn't feasible to adhere to the company-mandated testing process. You've got conflicting priorities here, and sometimes you accept the risk to make your boss happy. Usually you're okay, but sometimes it can blow up in your face. You're playing with fire when you test in production. It's like rolling the dice. Sometimes you're a winner, sometimes you're a loser. It's all about managing risk. So what is a cure for system hardening and testing? I'm not sure there really is a magic pill. The problem stems from the disparity between test and production. We've all been trying to build these test islands that represent production as close as possible, but it will never be the same. Production is way too dynamic, and you'd be forced to build test servers every minute during the day to keep up. Believe it or not, an excellent solution is to actually test in production, but not quite how you might think. It's something like a synthetic production environment, I kind of like to call it. Think of it as sort of like a layer on top of production that can be manipulated. For example, what if you had a tool that knew all of your application's dependencies? This is another one. Not only have you have this kind of synthetic production where you can kind of test in production, it also knows the dependencies as well. It could find out maybe if you change registry settings, which might affect a service on an entirely different server, or maybe just stopped a service, which would affect something else in a totally different data center altogether. I'm talking about something that essentially is production, but allows you to perform routine system hardening procedures without actually changing anything in the real production environment. This not only gives us better testing procedures because an automation tool will be keeping track of all the dependencies that us humans will probably forget, but it's also testing on production. It's not in a separate testing environment. This also saves a ton of time, which results in more thorough testing procedures and addresses security risks much faster. Now, don't you think this would lead to a much happier IT department all the way around?
All right, thanks so much, Adam, for your presentation. I'll give you a second there to catch your breath. For those of you in the audience, if you have a question at this time, please feel free to enter it in the Ask a Question box on the console. We'd greatly appreciate that. Today's webcast was sponsored by Calcom. For more information, you could go to their website. If you have questions about their specific products and what they offer, feel free to enter them in the Q&A. We will pass them on to representatives from Calcom so that way they could get back in touch with you. We have all your information, so if you have a question for them or on their products, please feel free to enter it at this time. We'll get to them. We'll get you responses to them after the webcast is over. But if you have a question for Adam now, please feel free to enter your question in the Ask a Question box for Adam. We'll get to as many questions as we can. So let me pass things back to Adam so that way he could peruse the Q&A. So Adam, go back ahead.
Okay. Well, thanks, Chris. I hope everybody enjoyed that webinar we went through. As Chris said, this is sponsored by Calcom Software, and that all of this was based on the system hardening procedures that their software does. I mean, I checked it out. It's really cool, kind of like that synthetic production thing like I was telling you about there in the slide. It's kind of like, the testing in production, but, without the risk. But anyway, so the first question we have here is from Phil. It says, do you know of any service or application that will index, classify, and monitor risks of every file resident on any electronic device? Well, let me see if I can kind of restate that a little bit. So it looks like you're looking for, you just want to I guess, measure the risk on a per file basis. I'm not really for sure if there's a service or a tool that will allow you to just point a tool at a hard drive or something with a bunch of files on it and say, this file is malicious, this file is not, this file has a risk from 0 to 10. But rather, there's a lot of tools that if there's a file in the Windows directory, it's all about context. So if there's a file in C Windows System 32, for example, or if there's a file on a data drive somewhere, the context of where the files are a lot different. But as far as tools, there's a lot of tools that kind of manage the risk of if a file is being executed or if a file is just sitting there at rest. One tool that I had used a while back was Tripwire. Tripwire.com was one that allows you to have an agent, and it goes through on a per file basis and kind of does what you're also talking about. And also as well, there's just your general anti-malware and antivirus tools will do that as well. You have your on-demand scan, which goes through like the big scan of all the files on your hard drive and does that thing. Or you have the real-time scan that's more monitoring things in memory. So as far as just monitoring, saying like pointing at a file and saying this is a risk of 0 to 10, that's kind of hard to say without the context. But what you could do is check out that Tripwire product, or really kind of look into the details of how these various anti-malware and antivirus applications get their definitions. Because once they have a new definition in their internal database, then they have that. They can look at that pattern of whatever malicious activity that that file is doing. So really, it looks like we're good to go. It looks like there's only one question here. And if you guys have any more questions for me personally, I would be happy to help out. You can get me on Twitter, or you can also catch me at adamtheautomator.com.
Yeah, cool. Thanks so much. And Nelson just asked the question if Calcom has a demo. Yes, they do. Nelson, we will. I'll pass your information personally along to the people over at Calcom, so that way they could get back in touch with you or where you could find that. They may even actually just send it to you via email when they reply to you. So I'll make sure that you have an option out there to try that out. But thank you all for attending today's webcast. Adam, thanks so much for your presentation. As always, very awesome, so thanks so much. And everybody in the audience, thank you for joining today's Redmond Tech Advisor webcast sponsored by Calcom. Thank you all for attending, and we hope you have a great day, everybody. Take care.